Very well. Sasa foto yangu inafanya nini hapa Joy?
Umesijawahi.
Yawa.
Tufanye Kahoot before afike. Leo I am squeezed. My time is so few. I had a lot to cover today. Actually, we will not be waiting for the rest, but I hope you've started your labs. By the way, guys, I didn't even have my lunch. Iko hapa tu inanukia vizuri, and I didn't eat. Let's just start. So start your labs. Go to the green AWS. Go to your console. On your console, come and search for Cloud9. You can just search it on the services and it's going to come up. And Cloud9. So Cloud9 is just like your normal VS Code that you use when you're coding. And you guys, you're going to forgive me. Python is not my language. I do not speak Snake, but my languages are more of applications based. So I practiced this guys for you. I had a code, so we're going to come and learn about it. But for Cloud9, you can use Cloud9 for whatever language that you want, okay? Cloud9 is an IDE, just like VS Code. And the way you use your VS Code to write code, run code, debug code is the same way you can do that on Cloud9. So after you've searched Cloud9, it opens this page. What I want you guys to do is come and click open on the Cloud9 IDE. Okay, you're going to see Restart Python Cloud9. This is an environment that has been created for this lab. I'm going to use it for an example. We're going to create a Python file. We're going to print something. We're going to save. What we're going to start with is something simple as the hello world. But also, I want to show you around Cloud9. So kindly come and click Cloud9 if you have anything to tell me. Please, please, please. Remember, I cannot see my screen. Let me see. Let me do this. Let me just let me see if I can split my screen. Yeah, well, kuona damu is not the easiest of things, Musembi. So yeah. Let me just right. I'm going to share my entire screen. And you guys tell me if you can see what I have here. Can you guys see my screen? All right. Perfect. All right. So once you come here on your Cloud9, once you come search Cloud9, it's going to open this environment that we've been created for by Restart. And let's open the Cloud9 environment and see what we have. I am a big fan of Cloud9 because Cloud9 is interesting because it's just like your VS Code and you can access it anywhere, okay? And as you can see, just like on your VS Code, you have the, what do they call this bar? Is it the taskbar? And you can see your files. We can have a terminal over here. You can create files. For example, you can go ahead and create a Python file on our, we've been told to call it what? Hmm. We've been told to name it as helloworld.py. Well, I am short of time. I'm going to save, the way you guys will save your files on VS Code, it's the same way. So I'm just going to save this as world.py because I do not have enough time to keep on writing a lot of stuff. So as you can see, my Python file has been created. And right here, we have our terminal. For example, you can run the commands, the Linux commands that we learned. For example, like we can do a cd to go back to where we are. All right. Let me just cd to the environment. All right. You can pwd to, you can print the working directory to know where you are. So you are in your environment. As you can see, when I listed, we got environment in Go. And you can do a few more things. You can create files. You can touch, for example, here we can touch a text.py file and it's created, right? You can rm the text.py file just like what we do on our normal terminals. All right, let me just clear this. And on our hello world.py, we can do a simple exercise of printing hello world. So I've done the introduction of the terminal. Yeah, we've been told here to run these codes to know the versions of our Python. So let's see, when we run Python dash dash version, what is the version of our Python? Our Python we're using Python 3.8. All right. And writing your first Python command. Right. So hmm, thank you, Daniel. Yes, AWS is actually very up to date. So let's print something on our hello world. Let me clear the terminal. Let me just clear. And let's write this code of printing hello world. So in Python, when you want to say output or show me, right? If you want to see something, if you want to see a text, you write print, okay? So we can just write print and we can write here hello world. All right. And then once you've done this, you can save your work and you can run right here on the top right. You can see run, okay? So once you run, what it does, the interpreter is going to look at your code and it's going to give you an output of your code. All right. So for example, let's say I want to say hello, I am a dentist, don't joke with me. And you run, it's going to give you an output of exactly what you've told it to print out for you. And as you can see, it has printed out for me, hello, I am a dentist, don't joke with me. So this is exactly how we output output content on Python. And that's the whole lab. But I had a code right here that I wanted us to run with. Let me just all right, so now this code right here, si ndio? First nimekuwa dentist. Mmeshaniambia niongezee kwa my skills, hata inaenda LinkedIn kileo leo. All right, so now this code is just a short code. I can have it here. You can work with it just to test. So what I did is what we have right here, we have a variable for name, which and it requires an input of asking you what is your name. So you're going to tell the program your name, and then it's going to welcome you. It's going to tell you welcome, and well, it's going to use your name, welcome Fulani. Let's do some math together. And then it's going to ask you for two numbers. It's going to ask you for the first number and for the second number. And then it's going to do a few calculations for you. So here it's going to give you an addition so of num1 plus num2. And then it's going to do a subtraction for you, num1 minus num2. It's going to do a multiplication for you of num1 times num2. And then it's going to do a division for you of num1 divided by num2. And then it's going to give you a modulus. What is modulus? And we are going to run. How many of you know modulus? Modulus in programming. Yes, modulus is the remainder. Okay. So we are going to run this code, this short code, and we're going to enter a name. Whose name would you want me to use? Because you're not talking, let me use the beautiful lady on my screen, Esther. Okay, we are told, welcome, Esther. So, welcome, Esther. Let's do some math together. So, as you can see, that's exactly what we got output as our output. And Esther has been asked to input the first number. Esther, are you with us?
I don't want to be with you, but yeah,
All right, give us one number. Give me one
random,
number.
random number.
Run as it can be.
9,
9. All right.
yeah,
And give me another number. So you've been asked to enter a second number.
7.
7. All right. So now, according to our short program over here, we are going to be, Esther has been given her results and she's been told 9 plus 7 is 16, 9 minus 7 is 2, 9 times 7 is 63, the division is 1.2, blah, 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 to 8, and the modulus is 2.0. Now, you guys, do you remember when you were talking about data types? So for our and we said that some programming languages do not need you to enter a data type. Do you guys remember? It's going to figure it out for itself. But now for us, our case here, we actually gave it a float. So if we gave it an int, it will have not have had all these decimal points. It will be whole numbers like 9 and 7. But because it has a float, it added the 9.0 and 7.0. So it's now a float because it has decimals. And with Python, it's just like any other programming language. You can create script files with it. You can create calculators with it. Like this is a calculator. You can create a project with them. You can create websites with it. You can create applications with it. You can do data stuff with it, analysis. I remember some point in time I was doing some bioengineering stuff with Python. So Python being a language is so open to a lot of opportunities. And now that you have an introduction to Cloud9, there is no point of you having to download VS Code on your machine for you to be able to write any piece of code. You can do it on your Cloud9, all right? You can. Sorry, guys.
Is everything okay?
Yeah. So with Cloud9, you realize that you can do virtually everything that you can do with your VS Code. For example, here, sorry, I have some mini humans who love my bedroom. So with Cloud9, you can create files, save them, delete. For example, if I wanted to even just delete my word.py, I'd just come here and file. Yes, I've actually interacted with Google Colab. I have. All right, I can just come here and delete my word.py just the way you would do. Cannot see delete. I have right clicked and I can delete. Yes, please delete and close my terminal. So Cloud9 is basically what you will get for an IDE, okay? And you guys, that is, I am not so sure. I have to research that for you. So, guys, I hope now you've understood something small about Cloud9. Let me just merge my tabs and I can share my tab. Um, there. So, guys, as if you've done that, you've already done Lab 108, and you see it's not hard, it's very easy. Cloud9 is just oh, thank you for that, SageMaker. All right, iko kwa vocarium purity ama I've
Hakuna.
just closed my Allah, wait, let me open my history. Let me check kwa grades kama nione kama inagradiwa. Interesting. Haina submit.
Yeah.
Let me just check kwa gradebook if I'm going to see lab 108. Allah. Hello
Even
world.
the next one haina.
Alright, so basi hizi ni za kufanya practices. Alright, so maybe they're not being graded. But doesn't mean that msifanye. It's fun to learn. Ay, fun. Fun, stop being happy. Fun misiani. Do not be happy. You cannot be happy because it's not being graded. I can see you're very happy people now, right? Hebu let's go unyo kwa unyo hadi debugging. I have less than 30 minutes to deliver two contents. Just a second. If you're happy and no, clap your hands. Aya, clap your hands basi mmeambiwa.
Joy, we can't hear you. Oh, you're muted, all right.
Yeah, sorry. All right. So let's proceed to debugging. Now that you can write your code on Cloud9, you can write anything that you want, any program that you want. You are bound to have um, instances where you're going to face bugs, right? Now, if you face bugs, what are some of the things that you can do? And specifically for Python, we are going to learn about a debugging tool that is embedded even in your Cloud9. Can you guys see my screen? Or let me just try and zoom. All right, perfect. I can see people are happy here until they're clapping. People, you're very happy. You don't feel like doing Python. I can see you. I can see you. Now, what is debugging? Debugging is the process of identifying and resolving defects or errors in a computer program. It ensures that your code behaves as it should and it meets the functional requirements. All right. So you find errors in your code and you fix them. That's the function of debugging. When you're finding errors, be able to locate the bugs, unexpected behavior in your code, and when it comes to fixing, correct the logic, the syntax, the runtime issues caused by the problem. Now, let's go to PDB. So PDB is a Python debugger, and it's Python's built-in interactive debugger that allows you as a developer to pause program execution, inspect variables, step through code line by uh, and step through code line by line to identify and fix bugs. Okay. So if you're still in your Cloud9, I'd love you to run this code and tell me. I've already closed mine. Run this code. Python. This one, Python dash m pdb, and then our file name was world.python, right? World.py. When you run this code, your debugger is going to be activated and it's going to run line by line and then prompt PDB, and then a prompt PDB appears. You can now use several commands, and all these tools are used to find errors and help developers find the reason between the errors. So if your Cloud9 is working, you have my code. Did I give you the code, you guys? I did. If your Cloud9 is up and you had this code, kindly run for me this code right here. And instead of the file name, use the file name that you stored it with. If you used hello world.py, world.py, test.py, whichever .py that you used file name, and then let me know what will happen. Now, you can, even as you're going through your lessons tomorrow, because today it was just a matter of introduction and introducing, especially people who are not into programming, having a bit of introduction knowledge before tomorrow's class. Tomorrow, as you're going to be learning about the different code lines of codes that you can use, functions, variables, and all those. Um, when you're running your codes, you can try and use this code for your debugger, so that as you're typing your code, the debugger runs, tells you where there's an issue, where you can improve. And also, as you're trying out certain things, I'd welcome you to try Amazon Q. Let me just have it here. Amazon Q. So Amazon Q is kind of like Copilot or ChatGPT. It's an AI by AWS that you can embed on your IDE like VS Code, and it will automatically be reading your code, advising you on what to do, where to change. If you're running through an error, it will debug the error for you. So you can try that also tomorrow as you're doing introduction to Python. All right. Are we together? Are we together? All right. Perfect. Yes, you can chat with it, Salem. You can definitely chat with it. All right, so let's go to the different types of debugging. We have static analysis and dynamic analysis. I think I need myself a glass of water. So, static analysis, right here. Static analysis, it examines your code without having to execute it. It detects syntax errors, code smells, and potential bugs before runtime. And it is often used in, do you guys remember I told you that we're going to check on CI/CD? Do you guys remember? I told you we're going to do short introduction on DevOps. So on DevOps, we have CI, and this is continuous integration and continuous deployment or development. So during CI, the continuous integration, you can use static analysis to detect syntax errors or code issues on your bugs, or even bugs, all right, on your code. And it helps enforce coding standards with best practices. Um, those who are in LX, for Python, do you guys remember that you used PyLint? Huh? So different types of static analysis debuggers are, for example, for Python, we have Flake 8, we have PyLint, we have MyPy. For JavaScript, we also used SLint. How many of you have come across those debuggers? SLint. And SLint would run before you even run your code and tell you you need to change this, you need to fix this, you need to fix this. And I absolutely love these tools because they do not wait for you to go into production for you to be able to see that you have a bug, or to run the entire code to tell you that you have a bug. No, they actually run even before you run your code and tell you that you can change this, you can do this better. For example, like Athlete will even tell you you can have this code in this way, which is a better way, a better syntax to having your code. So these are static analysis. They will run during your whole development process, and they're going to tell you you can maybe change this syntax error, you can change this semantic error, you have a bug here, you have written this code badly, you've forgotten to to add a semicolon, you have forgotten to close a bracket here, and that's a static analysis, all right? Now, its advantages, you can identify the exact location of code issues, and it has a faster turnaround time because you're not waiting to go to prod to fix a bug, right? You're fixing a bug right there during development. And later tests have fewer issues. So even when you're going to testing environment or even production, you have fewer issues, you have fewer bugs that you're dealing with. And another thing is that it leads to earlier detection of bugs, therefore reducing cost, time, stress. You guys, you've never slept a whole night trying to debug until you give up. Now, there are some disadvantages of static analysis, which is manual analysis is time consuming. Automation tools can produce false positives or false negatives. This means that maybe if you're going to use, for example, like an S-lint or PyLint, they can tell you maybe this line of code. I don't know, you guys, I'm pretty sure have had this. You've gotten through this issue. Maybe maybe ChatGPT or Claude AI or Copilot or Gemini, they give you a piece of code. You go run and you get an issue. You go to GPT again and to try and debug, it gives you another piece of code and it has even more issues, right? So there can be false positives or negatives, and automation might result in automation might result in taking security for granted. Automation is as good as the parameters you've set up for. All right. Uh, So there's an instruction guide for you guys here to create a file called debugging.py and write a basic program like the one we had for a calculator, and try have install Pylint and see whether it's going to give you errors. All right, you can try that during for example, during even right now. I don't know if anyone gave me an I don't know if anyone gave me an answer to no one ran the debug code, but you can try, all right? You can try and run a code debugging code and see how it will go. And then we have dynamic analysis. So for dynamic analysis, it debugs by executing the code and observing how it will behave. Its key features are identifying runtime errors, memory leaks, and logic flows. Do you guys remember when maybe you're coding with C and
Can you guys hear Joy? I'm the only one.
No, no, Wengia nyasi.
Joy, we can't hear you.
Alipotea.
Okay, let me call her.
I'm so sorry, guys. I don't know what's up with my Wi-Fi, but I've switched on to data. All right, so we've said that dynamic analysis, you're going to use debuggers, profilers, and logging systems. For example, like I did what? For example, you can use something like console.log. All right. Oh, sorry. Thank you. Thank you. Thank you. Sorry for that.
Salem, mute yourself, Salem.
Amesemaje jamani? All right. Dynamic debuggers are important for tracing bugs that only appear under certain conditions. And a good example of dynamic debuggers are, for example, wacheni kuingililia Salem. So a good example of debuggers in dynamic analysis are, for example, the PDB that we've seen, or PyCharm debugger, browser dev tools. In JavaScript, you use console.log, and the rest, the ones that you use that use debuggers. And the advantages of using dynamic analysis, it identifies issues in a runtime environment, either in your test server, in your live version of the software, and it can analyze applications even when you cannot observe the code, right? For example, a few times if you're creating an application, if you're going to use any JavaScript, for example, if you're going to use JavaScript or any JS that you want, if you're not seeing an issue with your code, you can do console.log. You can go to your console log and it can show you the underlying problem, right? So even when you cannot observe your code, you cannot see a problem, you can, it's okay, Silent. Leave these people alone. You just concentrate. I'll debug their minds. So you can, Belinda, you can you can use console log to see, is there an underlying issue on my code if you cannot see where the problem is. For example, if you are creating an application and you go to the application, you have your code, you've ran it, and you go to the application and you cannot see anything, you're just seeing a blank screen and you do not know where the issue is. You can use the debuggers to help you figure out what's going on. All right. When we go to assertions, all right. So assertions are runtime checks that validate whether certain conditions hold true or hold true during program executions. If the code fails, the program raises an error, and it helps debuggers. It helps. Gideon, GTT, it helps programmers to catch bugs early, all right? For example, first before we go there, characteristics of assertions are they act like conditional checkpoints similar to if statements, and they are used during dynamic analysis to verify assumptions about variables. And also, if an assertion fails, it will raise an assertion error, halting the execution and displaying an error message. All right. So, for example, like here, we have an example of log user age, and you enter your age, assert age should be greater than 0. If it's not greater than 0, for example, if you say that your age is -90, you'll be told invalid age was supplied. If we say that Salem is in between age 30 to 40, and Salem then tells us he's 55, we'll get an invalid age was supplied. So the assumptions work with checking whether certain conditions in your code have been met. For example, in our case, has age passed the age 0? If yes, it is valid. Proceed with whatever you're doing. If no, give an output message of an error that you supplied an invalid age. All right. For example, I can say here, let me say log user data, and then I say supplier. Assert supplier if supplier maybe here is someone is equals to Musembi. Output Uwongo. Uwongo, you're lying. So what it's going to do, it's going to check our charts and see what has Musembi said about my age, and it will output Uwongo. Uwongo, you have lied. All right. Mhm. Let's go to log monitoring. So, log monitoring is the process of continuously observing and analyzing log files generated by a running application. These logs record events, errors, and systems behavior. For example, you people, I'm pretty sure that you use log files a lot when you're creating a program, when you're creating an application. Maybe my application is for, maybe my application is here. Okay, let me just what can I say? I have an application that maybe let's say for example my calculator, right? The calculator that I gave you, and the program is running, right? And I have I am getting a certain error. Maybe I'm not getting the correct mathematics. What you can do, some programs they log their errors or even just data on log files, all right? And what you do, you go check that log file and look at the issue. And nowadays, because thankfully we have our artificial intelligence that helps us when our brains are not working correctly, you just go and copy at least. You can tell, say, around 50 of the logs and take it to your AI, and it is going to read for you your log file and tell you, we can see you have an error because maybe there are no dependencies of maybe the JavaScript dependencies, or maybe your database username is incorrect, or maybe your password is incorrect, your database password is incorrect. So what you do, you go read the logs and they're going to tell you where you have an error and you can correct it. So what to log? You can log system events, you can log your variables, errors, arguments, resources, and let me see. For those in programming, what are some of the log monitoring tools that you use if you're going to use an external, maybe monitoring tool? Some people are going to use Splunk. All right, use Sentry. All right, how is it, Brian? Some are going to use Datadog, especially if you're going to be someone like a solutions architect. It will be good for you to get used to Datadog. Datadog is going to embed itself on a cloud environment, and it is going to raise alarms when maybe there's an error. How is that, Gideon? All right. So we have several log monitoring tools like the ones you've mentioned. We can have Splunk, Elk Stack, Datadog, FluentD, all those. You can use all those. All right, we have a short demonstration and we can go to testing. The demonstration is telling you to All right. Test whether the value user supplies is greater than 0. All right, it's there. You can use the example I gave you, whether my age. If you hear anything from Usembi, just know that it is lies. Right, let's go to testing. We have different kinds of testing. We have acceptance testing. This is where I'm just going to read this through. Um, I'm going to explain this to you in an easier way. I am going to explain this to you in an easier way, and then we can go to DevOps, because I think the rest of, yeah, it's just explaining. So what is unit testing? Unit testing, it this is a type of testing that focuses on individual components or functions. It verifies that each unit of the code works as expected. So you run tests, small tests for isolated pieces of code or just for your logic. And to each part of, for example, you have, let me just give you an example. You have your our calculator code right there. And the first thing our calculator code was doing, it was asking you, enter your name. So what you can do with unit testing, first test whether the whole process of, number one, you've been asked to enter your name, you've entered your name, it outputs your name and greets you. Is it working? Is that part of the function working? Next, you go to the next part. You've been told to enter two numbers. So is the first part of entering one number working? Second part of entering the second number working? And if they are working, did they give you the right output when it was saying, dear Esther, you chose number 9 and 7? Is that true? And then you go to the third part of the calculations. Did the mathematical part give you the right answer? Additional part, did the additional part give you the right answer? Subtraction part, did it give you the right answer? All the way to the modulus. So it's like breaking down this whole code and running tests on smaller isolated piece of code. And then when they work, you know that the entire code is working. The advantage of unit testing is that, number one, it's fast and it is easy to automate. And you guys, someone like Musembi, I know you as a QA, you write a lot of unit tests, right? Musembi, as a QA. All right, so QA, people who are QA, they are not good friends with developers because they will do everything possible, humanly possible to them, to make sure that the
Kama
developers code is,
mnatuchukia tu.
developers na QA, they are not friends at all, because QA will look for every demon in a program. They will ensure you suffer, you cry silent tears. Then we can go to integration testing. So in the integration testing, the main focus is on the interaction is on the interaction between components, right? And each the goal is to ensure that each module works together correctly with the other module. For example, we can, if it's for the Zoom, we do want to test for the integration testing. We want to test whether, is the video working rightly? Is the video following audio correctly? Is the emojis, once people are sending emojis, are they being seen correctly? So integrating these different parts of the code and seeing how they work, you're running integration testing. Now, it tests data flows and communication between different units. For example, in a Zoom call, it will test the unit of video call, the audio call, the emojis, the chat, the recording, all that, all right? And then it detects interference mismatch between the logic, and also it is going to detect logical errors across different modules that are supposed to be working together, all right? For example, if you have your e-commerce site, you'd want to know, is my e-commerce site able to take data from the DB? So if yes, you know that the database by itself is working perfectly, the front end is working perfectly. So for the integrations, next, you can go to system testing. Now, with system testing, you're testing the entire application. You want to validate whether your it's producing what you expect. So, for example, if it's for Zoom, we're going to test being sent for a link, joining a meeting, muting and unmuting yourself, your video call, having your video on, having your microphone muted or unmuted, complaining. Can you complain on the chat? Yes, you can. Can you send funny emojis? Yes, you can. Can you record? So this is where we test the complete software in a simulated production environment, and it includes performance, security, and usability tests. All right. So here, if you create your whole application, you're going to test all of it. Is it working as it should? Is it giving you errors? If you wanted it to be able to maybe give you calculations of addition, subtraction, modulus, division, multiplication, is it giving you all those? All right. So you're testing your entire application. And finally, we have acceptance testing. And apart from this is my favorite type of testing. So here you want to compare the user requirements. So the user said, Esther said she wants a calculator that could give her addition, subtraction, multiplication, division, and modulus of her two numbers. Number one, you're going to check those user requirements and her goals and confirm whether your application is delivering that. So was she able to get her additions? Yes. Was she able to get her results of subtraction? Yes. Was she able to get division? Yes. Multiplication? Yes. Modulus? Yes. Was she able to enter her name? Yes. Was she able to do everything seamlessly? Yes. How easy was it for her to enter her name? Very easy. So all these are what you bring into acceptance testing. And just like Musembi has done, you as a QA, you are going to perform testing for both the end users and also for your developers. See whether whatever the developers gave you is what the client had asked for. And then we have people in project management who are going to tell the client, Esther, by the way, we can even create for you a physical calculator on the cloud. And then developers are going to cry. So is acceptance testing same as user testing? Yes, it is. I think so. It should be yes, because you're testing whether your users actually accepted your system. All right. Perfect. So we are done with debugging. Swiftly, let us move to DevOps. We finish up. All right. Here, let me just share my screen. And I split my screen and we can go. I hope you guys can clearly see my screen. Are you guys ready for some developer operations mindset? So who can tell me what is DevOps? What do you understand by DevOps? We finish up haraka haraka. These are just 20 pages. What do you understand by DevOps? People, what do you understand by DevOps? Develop operations working together in synergy. Yes, yes. Perfect. Another person? All right. Let's just do a simple introduction. Maybe you'll get a gist of it. All right. So, what is DevOps? Well, number one, DevOps is a mindset, a combination of IT tools to shorten SDLC. All right. Interesting. So, DevOps is a software engineering culture. It's actually a culture and a practice that aims at unifying the development and operations of software. All right. And the main characteristics of DevOps is movement is advocated for automation and monitoring at all steps. All right. So, you guys, I don't know if you remember. All right. So, here we have the culture, and the culture is for having a assign in the developers in the operations team, ensuring that we have automation. We are looking for errors. We are looking for errors. Our systems are working perfectly before going to the next step. Now, DevOps is a collaborative culture and a set of practices that bridges the gap between developers and operations, and it promotes a shared responsibility for continuous feedback and automation across the entire software lifecycle. Now, we have automation. A few things that we need to look at in DevOps. Number one, we have automation, and we said automation. This is streamlining repetitive tasks, for example, like testing, deployment, infrastructure provision. Now, you automate this using maybe automation tools that will do this for you, that you won't have to keep on doing them over and over and over again. Another thing that you're going to come in contact with during this lesson is continuous integration. So, continuous integration means developers merge code frequently and it triggers automated builds and tests. For example, you do not need to keep on going to type npm build, npm run, npm. No, when you're when you've automated your code, when you've automated your processes during continuous integration, as long as you push your code, say, to your GitHub, then it triggers automated builds. For example, it can build for you. For those who have used it's called GitHub. What is the automation tool for GitHub? I've forgotten. GitHub.
Actions.
Yes, good. Thank you. Thank you. GitHub Actions. So the moment you push your code on GitHub, you can have an actions playbook that's going to say, once I push my code, run specific tests. If everything is perfect, build my code and maybe containerize the application and send it to ECS or somewhere that you want to store, or Docker Hub where you want to store maybe your containerized applications. And then we can have continuous delivery, which ensures code is always in a deployable state, enabling frequent releases. So when you're when you're done now with the CI, next you go to CD. That's why they actually follow each other, CI CD. So this ensures that your code is always in a deployable state. So after it has been built, it has been packaged nicely, maybe it has been containerized. Next stage is maybe deploying it in ECS. So continuous delivery ensures that your code is always ready to be deployed. Once you push your code like this, higher CI does its work. It will run your test, it will automate the build for you, it will containerize application, send it to ECS. Now it will deploy your containers, and they can be it can the changes can be visible to the users. And then we have monitoring and logging, which will be actually very continuous as well, where you're tracking the performance of your system day in, day out. Track the performance and user behavior to detect issues early. And finally, the most important part of DevOps is collaboration and communication, where you ensure that the developers and the ops are actually in constant communication. And the operations won't say that you gave me a code that is not running, and the developer will say, I gave you, but in my laptop it's working. All right. So that ensuring that there's constant communication between different stakeholders when it comes to development is the key role of DevOps. Now, what is the culture of DevOps? Number one, um, we have, I don't know, have you guys heard of the CALMS framework? Has anyone heard about the CALMS framework? Where CALMS is, let me just have it here. So CALM stands for the culture which encourages collaboration, trust, and shared responsibility between developers and operations. And also, they're going to be working together, so no one really is blaming the other person. You can imagine a case scenario where the developer gives the ops code to deploy and manage on the cloud or on the server, and then the ops deploy and host the application. And then ops realize, wait, this code is not running. This code has errors. They go to the developers and they tell the developers, what is wrong with you? You gave me a code that is not tracking, that it has that a code that has errors, right? So instead of having a blame game situation in the workplace, you can cultivate a culture of collaboration, trust, and shared responsibility between developers and operations. And the next one is automation, where you reduce manual effort by automating the entire software lifecycle. It enables for continuous integration and continuous delivery. And then we can have lean, where you're eliminating waste and optimizing flow and delivery of value quickly. You can use small batch sizes and short feedback loops in iterative models to, for example, you can run something small, see how it works, get feedback, go to the next step, or maybe fix an issue that was there, then go to the next step. So you're taking short, bite-sized loops that will help you in creating and streamlining how you identify bugs and issues in software delivery. And finally, we have measurements where you can track performance, reliability, and user experiences using metrics. For example, you guys learned about CloudWatch, and you can use a service like CloudWatch to show you the deployment frequency. How fast is your code running? How many resources are being used when you do this? Is there a better way maybe to run this code? Is it important to containerize our application, or it can run as it is? Should we decouple our application, or we let it run like Musimbi and Sandra? And that's the culture of DevOps. So ensuring that you have continual experimentation, taking risk and learning, and repetition in practice to be able to solve issues quickly and be able to deploy your software in an easy way. So here we have a difference between, let me see this. All right. So, uh, for those who were in our very, very first classes, we learned about waterfall. So, what is the difference between waterfall and agile? These are two ways of software development. There are two, like SDLC. We can have waterfall, which follows a directed path. For example, you analyze the problem. For example, for waterfall, it's very straightforward. You're told to do this, after that, do this, after that, do this, after that, do this. In waterfall, you analyze the problem. After you've analyzed the problem and the user requirements, you create a plan and see what you're going to do, but what budget do we need, what language are we going to use. Design, you're going to create designs. For example, like you can use your flowchart and your you're going to use this. I can remember back in the day when we had to create uh what are we calling them? For example, like an ERD, was it, what are we calling it? Entity relationship diagrams. So you can design the diagrams to show you how your process flow will be. And then you're going to build where you code the entire product, and then you're going to test and deploy. But when it comes to agile, agile actually promotes DevOps so much because you're going to analyze and you're going to plan, you're going to analyze the problem and plan how to do it. And then the entire process of designing, building, and testing is continuous. So Rich, you're saying that waterfall is suitable for large projects that do not need iterative updates. Yes, actually, yes. So in Agile, you're going to iterate through designing, building, and testing. And once everything is perfect, then you can deploy. And you can go to the next sprint and the next sprint just like that. So Agile actually promotes DevOps so much because it's about improving your code and deploying it easily. What are the goals of DevOps? What are the goals of DevOps? So, DevOps aims at transforming software delivery by unifying deployment, development, operations, and assurance quality assurance into a seamless collaborative workflow. So with DevOps, you're going to find that developers, operations, and QA, they work together in harmony. So the developers are going to create code, the operations are going to see how the code works in the server, run some tests, monitor and log the output, continuously monitoring the code, and the QA is going to test whether there are bugs, and it's going to be a cycle. So DevOps aims at transforming software delivery by unifying these three people working together. Now, one of the goals of DevOps is to bridge traditional silos where it unifies the developers, operations, and QA into a shared responsibility model. Another thing is to accelerate delivery by promoting faster and frequent releases. So, the moment of you guys, you can imagine maybe you've not automated your testing, building, and deployment. It's going to take a while before you deploy. But if you automate, you're going to have a faster release of your changes. All right. And finally, is to integrate QA and security earlier on, ensuring that tests are carried out as soon as development starts, and therefore you can be able to catch issues and bugs earlier. Okay, so the organizational structure. So the culture can either support or hinder strategic initiatives in a company. A successful strategic change in a company must consider organizational structure. DevOps is a transformation that can be a strategy for building high performance. So this says that in organizations, especially the ones that do not have DevOps, you can introduce DevOps as a way of maybe a strategic change to see whether it's going to work for your organization. And you can develop a culture so that once it works, it will be a continuous process. Organizational culture types, we have collaborative culture. All right. Why culture first matters in DevOps is because culture will shape the behavior. So it influences how different teams are going to collaborate. Culture is going to accelerate or block transformation. So you can imagine if you go to an organization, for example, you come to Landly and you want to bring a culture of having KNI 53 and 54 working together. If it's not there, if we are not interested in working together, then we can block the transformation, right? But if we get a culture that accepts changes and would love to try something new, you can actually find that it could be easier for you to introduce something new. For Musembi and Sandra, I'd advise you to try some new things in your relationship. If flowers are not working, you can go for chocolates. If Sandra is not a sweet-toothed person, yeah, you can go to coffee. But Salem, you told me that you don't believe in dates. Huh? So if coffee doesn't work, maybe try buying her a house. A house could furahisha her, you know. I'm just saying. All right. Oh, Lanley. All right. All right. So try. It might work. I'm just giving you relationship advice. You know, I can also be a relationship mentor. Add that to my list of skills. Let's go to CI. Let's go to continuous integration, and we'll start with automation. All right, so in automation, we kwanza mimi nimetoka huko kwa Bim Safari. She's my neighbor somewhere. All right, so let's go straight ahead. Musembi Kamote will not work. A house will, and a title deed will, and maybe a Jeep or a G-Wagon, they might work. Kamote nowadays, it doesn't work. People are working on their aura and their energies. Kamote is not working. So let's go to automation. You know. So in automation, what do we mean by automating? This is where we automate repetitive tasks, for example, like testing, building, deploying, and provisioning resources. And the reason why we automate, we want to reduce manual effort and human error and context switching. For example, if Rage is used to asking for Chelsea, where's Chelsea? Where's Chelsea? Chelsea, are you back? Chelsea, are you in? Chelsea, are you in class? Chelsea, have you done your cases? Chelsea this, Chelsea that, Chelsea where, Chelsea here. Well, Ridge, you can automate the questions for you. You'll just run a script for you, right? We want to reduce the human error. Usije hapo ukaandika Chelsea vibaya without an A. And then you'll try and explaining to Chelsea, who's Chelsea? And we won't help you. All right. And now, see why automation is important? Because it will reduce your human effort and it will reduce chances of human error. Now, goals of automation: speed, faster execution of task. For example, if we were to run a script every day we came, yes, I love Ansible. It's one of my favorite tools. So let's say every time that we come to this class, Ridge has to ask for Chelsea and Musembi has to call out for Sandra. What do? We can actually automate the process for them, right? We can create a playbook and say, when Rich logs in, call out for Chelsea and ask, Chelsea, are you in class? If answer no, call Chelsea on 0700 If Chelsea answers, I'm in class, make sure that Ridge will smile and say hi to Chelsea. All right. So it's going, the moment you just log into class like this and you run the automation script, faster, we won't even have to wait for Ridge to text, to type. Typing is time. So we are going to have a fast execution of tasks of knowing where Chelsea is in class or not. And consistency. When you run the script every day, we'll be knowing that exactly at 8:45, Chelsea should answer yes or no. So, because already when you're running the script at 8:45, Ridge has already asked the most important questions. And Salem, makofi kwa Salem. Everybody clap for Salem. Makofi. Right? And having the script having the script file um having the script file is going to lead to consistency because it's going to be reliable. We'll be knowing that every day at 8:45 when Ridge clocks in and runs the script, there won't be issues. Ridge hatakosea, hakutakuwa na spelling mistakes. Scalability. If Ridge comes and finds Chelsea is not enough, he can say, let me add Belinda and Amy to the equation. So we'll just add Belinda, just from Chelsea, we'll just go and put a comma, add Belinda and Amy. And every time we run the script, so scalability is easy. It will be easy to grow the connection of Ridge and the three. And another thing is visibility. You'd be able to track and audit your process easily. And quality, you can be able to check for errors as soon as they appear. Now, there are risks that come with automation. And one of the risks is over automation. For example, for Musembi can over automate his script and say, for example, every day at 8:45, run Sandra.exe. Now, maybe Sandra.exe holds the name, holds the salams. Hi, Sandra. How are you? I am good this morning. I am looking for you. Have you done your cases and labs for yesterday? And then it can go overboard. And maybe he can ask, did you clean your computer? Did you update your machine? Have you updated your Windows? Did you buy a new phone? What's the name of your phone? So when it comes to automation, and maybe you have your application and you maybe want to automate the testings, right? Imagine hata kukula. So if you want to automate, you might find yourself over automating. People kindly give me just a second, I take a glass of water nisinyongwe hapa na maneno ya Musembi. I am back. Sorry for that. I really needed a glass of water. Leo sina ukwaju. Naboth. Makofi kwako Naboth. Hata mimi nitasema Sandra apelekwe lunch ama anunuliwe date ama umjengee kitchen kabisa ajipikie. So a risk that comes with automation, one of it is of automation where you're automating too much too soon, and this can lead to complexity and fragility. Sandra hasemi. Sandra anangojea mwenye kesi yake hapo nyuma ya nyumba. And then we can have under automation. With under automation, when you avoid automation to make sure that things are handled correctly, automation occurs when you avoid automation to make sure that things are handled correctly, and or because it is helpful to find exactly where the code stops. So if you are under automating, for example, those people who refused to create automation scripts to update their their systems, you might get that you either might forget to update your systems, or you'll have to manually keep on doing the work by yourself. And if it's something that you can automate, just go ahead and automate. And then we have bad automation, where it happens when automation does not work well. Bad automation can be fixed by visiting the planning stage of development. So you might find that maybe you automated testing, but you use the wrong test cases, right? Or the wrong test files. So what you can do, you can just go ahead and correct by going back to your development stage, planning stage, and correcting the issue. Now, tools for uh, automation in DevOps. Uh-huh. The automation tools are used to automatically compile code after change. We have build automation. We have different automation tools that you can have. You can have build automation, test automation, and deployment automations. For build automations, they are used to automatically compile code after changes have been made, and it is important because it saves time and reduces manual error by ensuring consistent builds across environments. For example, in AWS, we have AWS Code Build, which is a very good tool, by the way. When you go to if you'll be certifying for DevOps professional, you'll learn a lot about Code Build. And another tool that you can use for building, you can use Jenkins, you can use Maven, and you can use Gradle. When it comes to test automation, you automatically run logics and unit tests to validate the code behavior. And the benefit is that you're going to detect bugs early, and you're going to support CI, continuous integration, and improve code reliability. Some tools that you can use. How marketable is DevOps? Very, very marketable. Extremely marketable. Extremely marketable. Some of the tools that you can use for test automations, we can have code pipeline that is integrated with test stages. We can have Selenium. Someone was asked a question on Selenium yesterday. We can have JUnit for those people in Java, huh? And we can have Postman for APIs. Yes, and even PyTest. And when I go to deployment automation, you automatically package and deploy codes to testing and production environments. And the benefit of deploying automation is that it will reduce deployment errors, enable frequent releases, and support rollback and version control. So imagine that you deployed an application to your prod, And unfortunately, there was a bug that you did not catch. You can quickly roll back to the previous version that you had and fix up your issues. So some of the tools that you can use for deployment with sleepers. So some of the tools that you can use for deployment automation are, for example, in AWS we have Code Deploy, one of the services that I love. You can use GitHub Actions, you can use PinMaker, you can use Terraform, and even Terraform you can use Terraform for infrastructure as code, right? To deploy to create for you infrastructure. All right. So the CI/CD pipeline, I think I've gone through this a lot, and we said for CI is continuous integration, where developers frequently merge code, change, merge code, where higher continuous integration. This is where developers will merge their nichekeni tu. Asante Musembe. I am actually very tired today. I am so sorry. So continuous integration, this is where developers will merge their code changes into a shared repository. And what does that say, Frank? Is this Japanese or Korean? Let me see. I drink more hot water. Yeah, I didn't get a chance to warm my water. I just took it cold. No, I need water. I need a lot of water. I've not even eaten anything from yesterday. So I'm hungry and thirsty and tired at the same time. So for continuous integration, we as the developers, we are going to merge our code changes in one repo, and this will provoke um, automated builds and automated test runs for our code changes. And in continuous development, the code that passes the CI, the test, and it is built correctly will automatically be packaged and prepared for the deployment, right? To either the staging environment or the production environment. All right. So you can deploy either on your EC2 instances, you can deploy on your ECS or EKS, or in your uh, Docker containers, or on your Contabo server, whichever server that you're using. All right. And all right, I think we're done. But before we finish, I'd like to give you a tip of the CI/CD pipeline that you can have in AWS. So first, we have code commit. Let me just share this with you. We have code commit. So imagine code commit as your, for example, imagine code commit as GitHub, right? It's Git. You use this for version control and you push your code there. So what happens is, and what's this Chinese solution? Share with me, it might help me. So after you've pushed your code to code commit or Git, your code will be compiled and packaged, and tests are run automatically. We can use code build for those two, and release your code is approved. Code's approved version will be released and deployed, and you'll also continue monitoring your application, rather your changes and your software, right? Yeah, it can stand for either continuous delivery or continuous deployment, depending on how you're using it. All right, guys, a checkpoint question. I see if you were with me. So, DevOps is a bridge between what areas in software development? DevOps is a collaboration between who and who? It's a bridge between what areas in development? People, are you hearing me? Very nice. Yes, development and operations team. Name three risks of automation. Name three risks of automation. Name three risks of automation. Over automation. Mm-hmm. Another one. Name three risks of automation. So we have over automation, under automation, and bad automation. Perfect. So let me first confirm something from you people. Roy, is Roy in class? Is Roy in class? I saw him leave. What, Mark, what's up? What's funny? Brian Kipkirui, are you here? And Brian Mureithi, these people are absent. Roy, are you in class? Juliet, Tony, Juliet, Tony. All right, Tony. Wewe ndio huko Basil. Juliet, are you with me? You know, if my boss comes and finds you people are not in class, in fact, she's here. Oh, Esther is here. Priscilla. Priscilla did not come. All right, Juliet. Purity, Prudence. Sorry, not purity. Prudence. Prudence is not in. All right. Roy. All right, no problem. So you guys have a great evening. Get ready for tomorrow. So tomorrow we'll be doing a deep dive on Python, right? So today I was just doing an introduction. I was laying a foundation for those people who do not know anything in programming. I did not want to be complex, and I wanted you people to have at least a taste of what you're going to do tomorrow. Now, you also had a taste of Cloud9 and how you're going to do your labs from today for the Python. So, guys, tomorrow will be a marathon. It will be a marathon just like today.